Okay, let's give you guys some more practice. So somehow integrate this. So press pause and have a go. Okay, so to integrate this, we should use partial fractions. So we need to break this up. So imagine this thing here as being bubble equals x squared. Now if you look at this here, this is like me saying bubble squared, and then this bit here plus 4 bubble, and then this here is a constant. You see, this thing here is very similar to me giving you this x squared plus 4x plus 3. If you were to factorize this, your eyes should zoom into this 3. Two numbers multiplied together to give you 3. It can only be 1 under 3. So to factorize this, you would immediately jump to this plus 3 and then x plus 1. Well, in order for you to factorize this, you can immediately jump to this bubble plus 3 and then bubble plus 1. Well, earlier we said x squared is, the bubble is x squared, so you can put that into here, so that would be x squared, and then put this into here, so this would be x squared. The point is that you can rewrite this as this. You can rewrite this as this. Okay, so we are trying to integrate this, but rewrite this as this. So once you're in this form here, you can break the fraction into two separate fractions. So remember from our section on when we were trying to integrate, we need to use partial fractions. This here is a quadratic. So when it's a quadratic, we would need the numerator needs to be linear. So if this here is linear, let's say if this here is x plus 7, whatever's at the top, then here you can have a constant. You can have just capital A over x plus 7. But because this here is a quadratic, you will need a linear. The numerator needs to be a linear, and then this one here, this here needs to be a linear. So if you don't understand what I'm talking about, then you need to track back to one of the early videos. Well, in order to break this up into two separate fractions, because it's a quadratic here, we need this to be a linear. We need this to be linear. Okay, so this thing will be one fraction plus another. So now it's just a matter of finding out a, b, c, and d in such a way that this whole thing here equals this. Okay, so to find out a, b, c, and d, let's merge these two fractions together. So multiply this by x squared plus 1, and then so we're multiplying top and bottom by x squared plus 1, and then over here multiply top and bottom by this thing here. So basically we're just merging the two fractions together. Okay, so the x squared plus 3, x squared plus 3. Well, and then the two denominators will be the same, and then you can merge the two numerators. Well, let's just concentrate on the two numerators. If you merge them together, it will give you this. And then if you look at this the denominator here and here will be the same. So just ignore it and let's just concentrate on looking at the numerator. So we want to find a. Well, if you merge these two fractions together, the numerator will become this. Okay, and then if you look on the left hand side, let's just compare the numerator over here. So now we need to find a and b in such a way that this a, b, c, and d in such a way that that this whole thing here will equal this. Okay, so let's multiply this out. So hang on. So now we need to multiply this out. So this times this will give you this. 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 And then do the same over here. This times this. This times this. This times this. And this times this. That will then give you this. And then group everything together. So hang on. So we are currently here. So now group everything together. X to the power 3. X to the power 3. So group these two together. So it's b plus d. And then next one would be x squared. You've got x squared here, x squared here. So group the a and the c together. That will then give you a plus c. And then the next one would be would be single x and single x. So b plus 3d, b plus 3d, and the last one is a constant, single number here. So yeah, so just tidy up. It will then take you to here. Now it's just using basic simultaneous equations here. If you look at this, we want to find a, b, c, and d in such a way that this whole thing here equals this. So meaning that we need to set this to be 0, because you're gonna have, because if you look on the left hand side, there is no x to the power 3 on here. So on the left hand side, there's no x to the power 3. So somehow make this to be 0. If you look at this, on the left hand side, there's no x squared term. So we need to somehow make this to be 0. If you look at this, we would need this. Well, here you've got 1, 1. So we would need to make this to somehow be equal to 1. Okay, so that's this thing equals to 1. And then we need to somehow make this to be, well, there's no constant, there's no single number over here. So we need to make this to be 0. So looking at this here, this needs to be 1. Well, if this is 1, and let's look at this. This needs to be 0 here. So let's just take away d from both sides. That will then give you this. Now we can put this into here. Blah blah. It's quite yeah. Blah blah. So d equals a half. B equals negative a half. And the others must be 0. Okay. The others must be 0. If you think about it, the others must be 0. So d equals a half, b equals negative a half. So now back to this thing here. We know a needs to be 0. We know b has to be a half. We know c has to be 0. This has to be a half. So put everything into here. It will then take you to here. Okay? It will then take you to here. It will then take you to here. Tidy this up. It will then take you to here. And now it's just so now you can visualize it as this. So now we can now just integrate this and integrate this. Well, integrating this, well, no, look at this. This here is almost the exact derivative of this. So when you when you integrate this, it will give you when you integrate this, it will give you a half natural log of absolute of 1 here, but you don't need the absolute here because this here will always be a positive. So well, this half you need to times it with this half. That will then give you a quarter. Well, integrating the whole thing here, we've done this many times, will give you this. Okay, so when you have one thing, take away another thing, so that's the same as this divided by this. Well, your final answer will be this. Okay.